Welcome to today's CAD lesson. In today's exercise, we model the universal joint. A universal joint or a U-joint transmits rotary motion and torque between two shafts that are not in a straight line, allowing for angular misalignment. This assembly will consist of 5 parts. We have the yoke, the cross, the bolt, the bush, and the pin. We would assemble just like you see and also animate just like you saw in the beginning of this video. If you would have any comments, questions, concerns, or contributions at the end, kindly drop them down in the comment section below. I would respond to them as soon as possible. Let's begin with today's exercise. There are 5 parts in this assembly. Let's begin with the first one. Let's get a new worksheet, and so click on new app here or Ctrl+N. Under part create 2D and 3D objects under the metric tab here. Let's select the standard MMIPT and hit create. The first part we want to model is the yoke. Let's begin that by clicking on the 2D sketch command up here. We want this sketch to be extruded from the XY plane, and so I would select that. Now let's go into our rectangle tab. We'll pick the third one that says the 2-point center rectangle. We'll bring that to the origin and draw a rectangle here. We will then dimension, and so the width of this rectangle is 120. You can type that in here and check. And for the height, we would also give that a height of 180, and we will check that. Now let's finish this sketch. Double click the scroll mouse button so you get your work in focus. We want to extrude. The extrude command. The profile has been automatically selected since there is just one closed profile. The distance of extrusion here, we want to change that to 30. The direction is going to be the first one, the default. Everything is fine. The preview looks good. We will go ahead and OK. Now also on this face, we want to create another sketch. We will pick the circle command and draw a circle here from the origin. We will draw another one and pick the dimension command. We will dimension this bigger one as 100, and the smaller one will give that a diameter of 50. Let's enter that. Now we'll pick the line command. Let's draw this profile here. Make sure this line is vertical. We'll draw a perpendicular line to that, and we'll connect that vertically to the circle. You can right click and then OK to get off the line command. Now we will dimension. The height of this is going to be 7, and the width is 15. Now we would apply the vertical relationship between the midpoint here of this horizontal line and the origin. You can right click and OK to get off that command. Now what we want to do is to trim off this part of the circle. So just hover your mouse here. Once you see those dotted white lines, it means that is the part you are taking off. You can just click, and there we go. We can finish the sketch and extrude that profile. The extrude command. The profile is going to be this inner one, so select that, and we want to extrude that to a distance of 100, and so I'll type that here and we would OK. In the next step, we want to extrude from this face, and so I'm going to select that face and create a sketch on there. Now I want to rotate this view cube around so that I can read the top from the left to the right. Let me also zoom in a little. Okay, let's pick the circle command. I'm going to draw 2 circles here. Okay, so this is going to be the first one, and that is going to be the second. I will dimension the first one with a diameter of 92. Let's enter that. For the second one, is going to be of diameter 32. Let's enter that as well. I would apply the vertical relationship to align the center point of those 2 circles vertically with the origin, and also dimension the distance between this line here and the center point of those 2 circles as 60, and enter that. Okay, next pick the line command. We want to draw a line from the origin here. Let's make sure we touch the circle. We'll do same from this corner also to the circle, and apply a tangential relationship between this line and the circle, also between this line and the circle. Now pick the trim command up here, and we want to take off this part of the circle. Now you can go ahead and finish this sketch, and we want to extrude the extrude command. We want to extrude this profile, but the direction of extrusion as well as the distance of extrusion is not what we want. We'll change that from the behavior. The direction we'll choose the flipped, and the distance of that extrusion we want to change to 30. The preview looks fine, and so we would OK. Now we want to create this same feature here on the opposite side. We can use the mirror command for that. Let's pick the mirror command up here under the pattern group. The feature we want to mirror is going to be this extrusion 3 we just did. You can select that from the model browser. For the mirror plane, which is the plane it should go across, we can pick, let's see, the XZ plane. Once you select that, you will see the preview. That is what we want. We would hit OK. This part is ready. We will just save it and change the appearance. Let's change the appearance first. So drop down the appearance options. We want to change this to galvanized. So you can type G to move to the G column and look for galvanized. Okay, so there I have it. I'm also going to save this into a folder I had prepared prior to this tutorial. It is called the universal joint. I'm going to save this in here as part number 1, yoke. Now we can move to create the second part, which is going to be the cross or the spider. Let's get a worksheet for that new up here. And the part create 2D and 3D object. This is also a part, and so we'll select a standard MMIPT and create. Now let's pick the 2D sketch command and create the sketch on the XZ plane or the top plane. Now let's rotate this view cube so we can read the top from the left to the right. We'll pick the circle command. Let's draw a circle from the origin. We will draw another one and dimension. So for this bigger one, we would give it a diameter of 60, and we will change the diameter of the smaller one to 30. Let's enter that and finish this sketch. We would extrude the extrude command. The profile we want to extrude is going to be this profile. The direction we want that to be symmetric. The distance of this extrusion we will change to 120 and OK. We would also pick the 2D sketch command again and create a sketch on, let's see, the plane we want to create the sketch on. We can do the XY plane, and so I'll select that. Now we'll pick the circle command. Let's draw one circle here. We will draw another one. We see part of these circles are missing because the plane we chose is lying in the middle of this feature. Come down here, choose the slice option to slice that feature into 2 so you can see those circles. Now we would dimension, the dimension command. The diameter of the bigger one will be 60. The smaller one will be 30, just like we did before. And we will dimension the distance between the origin and the center of the circle as 46, and apply the horizontal relationship to align the center point of these two circles with the origin horizontally. You can right click and OK. We would finish the sketch and we would extrude it. The profile we want to extrude is going to be this one. The direction will be symmetric as well. The distance will be 120 like before. The preview is fine. We would hit OK. Let's inspect what we've done. Okay, this is exactly what you should get. Now we would apply a fillet, the fillet command. The fillet radius is going to be 10 mm. We'll type that in here. Let me turn this around. We want to apply that to this area and hit OK. This part is ready. We'll change the appearance also to galvanized. And we would save this as the part number 2, the cross. Now we'll go ahead to create the third part, which is the bolts. Let's get a worksheet for that new up here. Standard MMIPT we would create. Now let's pick the 2D sketch command. We would create the sketch on the XY plane. We would use the revolve command to model the bolt. First of all, let's pan to the left so we have enough room to create our 2D sketch here. Now pick the line command. Let's draw this profile from the origin. We'll draw a vertical line. Just drop that here. Let's draw a diagonal line. We will draw a horizontal line from that point. Let's draw a perpendicular line to that. We would also draw another perpendicular line horizontally. Let's draw a diagonal line towards the right. We would draw a vertical line to the origin. And let's connect that back to where we started. You can right click and OK. We would dimension the distance between this horizontal line and this horizontal line is 24. Would also have the distance between this point here and this horizontal line as 2. Also between this point and this vertical line as 2. Let's enter that. The length of this line is going to be 16. Also between this line and this one is 16 as well. Let's move to the opposite side. Also between this point and this horizontal line will be 2, just like we did on the opposite side. Between this point and this vertical line is 2 as well. And we would finally dimension the distance between this vertical line and this one here as 208. Let's check that. Okay, our sketch is fully constrained now. By click OK to get off the dimension command, we will select this horizontal line and make that a center line. That will aid in the revolution of this profile. Let's finish this. Let's choose the revolve command. The profile has been correctly selected. Because we had a center line, it has noticed that center line at the axis of revolution. That is why we see the complete revolution here at an angle of 360. Let's OK since the preview looks good. Okay, now we would create a little hole in here. Let's pick one of the planes to work on. We can work on the XZ plane. I would select that and choose create sketch. Now let me turn this around so I read the top from the left to the right and also slice. We can pick the circle command. Let's draw a circle here of diameter 8. Enter that in the dynamic input box and press enter. We would apply the horizontal constraint between the center point of that circle and the origin. And then we would dimension the distance between this line here and the center of this circle as 188. Now we can finish this and we want to extrude that profile. The direction should be symmetric. The boolean, we want to remove material, so we'll select a cut. And we want the distance of that cut to go through all. So we can go through this entire feature. Now we can hit OK. This part is done. Let's have a look at it one last time. Okay, now we can go ahead and save this as the part number 3 bolt and even change the appearance to one of these metal colors. So type M to move to the M column. You can select the metal 2400 FH. Okay, now we would save again. Now to the third part, let's get a worksheet. We would pick the 2D sketch command and create the sketch on the top plane. Let me turn the view cube around. Now I'll pick the circle command. Let's draw 2 circles from the origin. I would dimension one of them with a diameter of 40, the other one with a diameter of 32. Now I'll finish this and extrude this profile right here to a distance of 16. Let's OK that. Now let's pick the XY plane and create a sketch on it. Let's slice so we see that plane. Pick the circle command. Let's draw a circle here. We will dimension this with a diameter of 8. Let's apply the horizontal relationship between the center of the circle And okay, we can't do that, so right click OK to get off that command. First of all, we would project this line so we can use it to apply the horizontal relationship. Now find the midpoint of this line and the center points of the circle. Would also apply the vertical relationship between the center points of the circle and the origin. You can right click OK. Let's finish this. We would extrude that profile that has been automatically selected. The direction should be symmetric. The distance, we want that to be through all. The boolean should be a cut. Let's OK. We would apply a fillet of radius 2 mm to this edge and this very one. Let's OK. Now we will change the appearance of this to the black cast, and I'm going to save this as the part number 4 bush. Very simple part. Now to the last part, very easy and simple part. Let's get a worksheet. Standard MMIPT create. We will create a 2D sketch on the XSA plane or the top plane. Let me turn this around. Pick the circle command. Let me draw a circle from the origin of diameter 8. We would enter that. Now you can finish this and extrude that profile. The direction can be symmetric. The distance of extrusion, let's make that 40 and hit OK. We would apply a chamfer. The distance of this chamfer is going to be 1 mm to this edge and the opposite edge. Let's hit apply and close this. Now change the appearance of this also to the metal color I used before, which is this one. Now let's save this as the part number 5 pin. Now we have all our 5 parts ready, so you should have the pin, the bush, the bolt, the cross, and the yoke. Now we can go ahead and assemble. Let's get a new worksheet. This time under assembly, assemble 2D and 3D components. Since we are assembling, we will select the standard MMIAM sheet template and create. Before we do anything, let's go into the View tab and change the visual style to shaded with edges. Now we'll go back to the Assembly tab. Let's bring in our first part and so hit Place and locate the folder in which you saved your works. For me, this is here. I'll bring in the first part as the yoke, so just check that and hit Open. Now you can click to place that here and right click OK. What we want to do to this is to ground it. We would unground it anyway, but to aid in our assembly, we just want to ground it for now. So just click on it, right click and choose the option that says grounded. Okay, we can bring in another part, hit on place again. The second part is going to be the cross, so just check that and open. I'm going to drop that here. You can right click and then OK. Let's put those two together with the constraint command here under the relationships. So hit constraint. The type is going to be the first one that says mate. The solution is going to be a mate as well. And we want to apply that mate, which is a concentric mate between this hole and this hole. You can hit apply. Let's turn this and see. Okay, we would also want this face to sit on top of this face. So the type is going to be a mate again, the solution a mate. We'll select this face. Let's turn this around and select this face as well. So we have it sitting, or those two faces attached. Let's hit apply. Now I'll close this. Let's see what we have. Excellent. We'll bring in another part, hit on place again, the yoke again, so just check that and open. Don't click to place yet. Right click rather, choose rotate Y90. We'll do that a second time so we have it facing this way. We'll also want to rotate Z90. Okay, so we have it facing this way. Just click and place it. You right click and OK. Let me get the isometric view so we get a better picture of what we've done. Now we would constrain again the type mate, the solution and mate. We want to align this hole concentrically with this one. Let's hit apply, and we would also apply a mate between this face and this face. Let's apply and close this. Now let's see. Great. We want to bring in the bolts now. So hit on place again, select the bolt, just open that. Let me drop one of it here. You can then rotate Z90 so you get one also facing this way. Let's drop this here. You right click OK. We want to put this also in this assembly, so constrain. This time the type is going to be an insert. We want to say that make this circle here sit right on top of this very one, and also align those two holes concentrically. So I'll select this second hole as well and hit apply. Let me do same also for this edge here and this very hole. Let's hit apply. We can close this. Let's get the isometric view. We can bring in another part, which is the bush. Let's hit on place again. Bush. Let's open. Let me drop one here. I would rotate Z90. Let's also drop the second one here. You right click and OK. Now we want to constrain. Let's constrain concentrically this hole with also this bolt. Let's apply and also align this hole here with the corresponding hole on the bolt, which is this very one. Now we can apply. Okay, so we have that hole. We'll do same for the other bolt. So we'll apply the concentric relationship between this bush and also this bolt, and also align. Hit apply first and also align this hole concentrically with this one. Let's hit apply and let's close for now. Let's see if those two holes are aligned. Okay, perfect. Let's get the isometric view. We are left with the pin. Let's hit place. Pin. Let me open. I would drop the first one here. You can right click, rotate Z90. We'll draw the second one here. Right click and then OK. You would also constrain concentrically this and this hole. Let's apply and then also put a mate between this face and this one, but it's going to sit in the middle. So let's set an offset of -20. So we align it to this edge. Let's hit apply. We'll do same for this pin. Let me turn this around and locate the hole, which is right here. Let's apply and then do a mate between this face and this one. We'll set our offset to -20 and hit apply. Now we can close this. Let's see. Okay, that has been neatly done. Okay, this is exactly what we want to see. Right. Now what we want to do is to unground this part so we can apply our animation. So just click on it, right click and do grounded, or check that off. Let me also constrain this and that one, just so I get them in the right alignment, but I would even suppress it anyway. So just click suppress and apply. Let's close this now. Let's see. Okay, we can now apply our animation. Let's apply an angular relationship first. So constraint, the type is going to be angular. The solution is a directed angle. We want to apply that between the yoke, which is the first yoke. So locate the default planes and let's choose the YZ plane. And now open the open the origins of the assembly and also select YZ plane. The directed angle is going to be between those two. Let's hit apply. Let's close this. Now let's look for that angle, which is this one. So click on it, right click and choose drive. Let's play and see. Okay, that is not the motion we want. I know what is happening. Okay, so let's close this first. Let's now constrain. Let's do the z-axis of the main assembly and the z-axis of the yoke. Let's apply. Let's close this. Now let's drive and see what is happening. Okay, exactly what we want. Great. Now I'll change the end to about 360 and play. Okay, so we can see a little bit of angular relationship between the two yokes, but notice that this first yoke here is going into the second yoke, which is not what we want. So close this for now. Let's go into inspect, look for activate contact solver. Let's put a contact solver between this yoke. So select that, hold down control key, select the second yoke, right click and choose the contact set. Now once we drive, those two won't go into each other. It would stop at that particular angle where those two faces sit against each other. Let's drive and see. This is the angle. I click, drive. Now, okay, the end is 3,600. I've changed that from 360 to 3,600. I think it was 3,600 actually. Let's play. Okay, so we see that angle here has stopped. Even as it rotates, this yoke won't move any further. Okay, this is exactly what we want to see. You can even open this up for more options. Let's do total number of steps. We can reduce this to 2,800. Let's play. So we increase the speed a little. Let's play forward and backwards. Okay, let me close this, go into view. Let's do a basic rendering, add a shadow, add a reflection. You can add a ground plane if you want. The lighting effect is fine. Let's try one last time. Let me increase this. Okay, and play. Alright, and so that's going to be it for this tutorial. I hope this has been helpful. If it has, give me a thumbs up. Do well to subscribe if you're yet to do that. Also do well to share this with your CAD friends. If you have any comments, questions, concerns, or contributions, kindly drop them down in the comment section below. I would respond to them as soon as possible. Don't forget to save this. I'll see you soon in the next tutorial. Bye.